going to discuss about the determinant of a matrix, singular, non-singular of a matrix, adjoining of a matrix, and inverse of a matrix with example, and upcoming videos related with problem related determinant, singular and non-singular matrix. Let's take a start from determinant of a matrix. You can see here we have a definition. Determinant. A determinant is a number associated with a square number matrix when the element of a square matrix are enclosed in a vertical line, this to a vertical line, without changing their position, then it is called the determinant of a matrix. The determinant of a square matrix A is denoted by determinant A. This one is read as determinant A or determinant or det A. If A is equal to A, B, C, D, then how to find out determinant? Look at here. If A is equal to A, B, C, D, then determinant A is equal to what we can write here. You can see here we have to write inside this two parallel vertical line without changing their position. Means what is here written A, B, C, D, we have to write down same A, B, C and D. Now how to find out determinant? We have to cross multiply. Now look at here. First of all, we have to multiply the diagonal, main diagonal A into D. We have to multiply A and D minus non-diagonal. We have to multiply non-diagonal C into B, or you can write here B, C. Again look at here, determinant A is equal to, we have to write down each and every elements without changing their position, A, B, C, D. So we have to write A, B, C, D, and after that to find out determinant we have to multiply the main diagonal. Main diagonal means AD, A into D, AD minus, always minus, and then non-diagonal we have to multiply C into B, BC or CB you can write on. Look at one more example here in numbers. Take out one example. Suppose question, if A is equal to 1, 3, 2, 4, find determinant A. We have to find out determinant A. So how to find out this determinant A? Here, what is matrix A? Matrix A is given here 1, 3, 2, 4. Now we have to find out determinant A. So determinant A is equal to, we have to write on each and every elements without changing their position. What is 1, 3, 2, 4? So we have to write 1, 3, 2, 4. Do not change their elements, okay? And we have to write inside that vertical line. After this we have to multiply the main diagonal 1 into 4. So 1 into 4 minus, always we have to write on minus. After that 2 into 3, 2 into 3, multiply non-diagonal. First of all, main diagonal we have to multiply 1 into 4, 1 into 4, always minus, then 2 into 3, non-diagonal we have to multiply. Now 4 into 1, 4, minus 2 into 3, 6 is equal to minus 2 is the answer. Now look at singular matrix. You can see here the definition of singular matrix. A square matrix A is said to be singular if its determinant A is equal to 0. Determinant A is equal to 0. If determinant A is equal to 0, then that matrix is known as singular matrix. For example, take it one example. If A, we have matrix A is equal to 6, 2, 9, 3. Either this is singular or non-singular. How to find out? By finding determinant. So A is equal to this. So first of all, we have to find out the determinant. We have to write down each and every elements without changing their places, and we have to write inside parallel line, vertical line. So 6, 2, 9, 3. Now find out the determinant. First of all, we have to multiply the main diagonal 6 into 3. 6 into 3 minus 9 into 2. 9 into 2 is equal to 6 into 3, 18, minus 9 into 2, 18 is equal to 0. Therefore, determinant A is equal to 0. According to definition, what is here? A singular matrix A is said to be singular if its determinant A is equal to 0. Now you can see here determinant A is equal to, we got here 0. Therefore, we can write down A is a singular matrix. Hope you understand the definition of singular with example. If determinant is 0, then singular matrix. If determinant is not equal to 0, then non-singular matrix. Now look at the definition of non-singular matrix with example. A square matrix A is said to be non-singular matrix if its determinant, that is determinant A, is not equal to 0. If determinant equal to 0, then singular matrix, which we done before, and if determinant is not equal to 0, then non-singular matrix. So you have to focus how to find out determinant. First of all, let's take an example. For example, if A is equal to matrix A is equal to 9 6 8 6, then for either this is singular or non-singular, we have to show by finding determinant. We have to check it by finding determinant. Determinant A is equal to, we have to write down in vertical line without replacing the numbers. So we can write here 9 6 8 6. Now multiply the main diagonal, 9 into 6. 9 into 6 minus non-diagonal, we have to multiply the non-diagonal, 8 into 6. First 9 into 6, multiply the main diagonal minus from formula and non-diagonal. Now multiply this, 6 9s are 54 minus 8 into 6, 48 is equal to 6, which is not equal to 0. So therefore we can write determinant A is equal to 6, or that is determinant A is not equal to 0. So if determinant A is not equal to 0, then that type of matrix is known as non-singular matrix. Now look at the definition of adjoining of a matrix. A matrix obtained by interchanging the elements of the main diagonal or of the leading diagonal. You can write anything. And the sign of the remaining elements. Remaining elements of 2 into 2 matrix is known as adjoint of a matrix. Look at the properly. A matrix obtaining by interchanging the elements of the leading diagonal. Leading diagonal means main diagonal, and the sign of remaining elements of 2 into 2 matrix is known as adjoint of a matrix. For example, if we have A is equal to A, B, C, D, then adjoint of A is equal to, what is here? Interchanging the elements of leading diagonal. It means we have to interchange this two. Interchange the elements of leading diagonal. Main diagonal means we have to change the elements. So in the place of A we have to write on D, and in the place of D we have to write down A. Interchange A and D. And the sign of the remaining elements. Now we have to change the sign of remaining elements means B and C. We have to change their sign. If positive, we have to write negative. Here is plus B, so we have to write on minus B. Here is positive C, we have to write on negative C. But if negative, if minus B, then we have to write plus B. I will show you one more example here. If we have A is equal to 3 minus 4 2 1, then adjoining A we can write A D J also. Adjoining A is equal to, what we have to do, we have to interchange the leading diagonal. We have to interchange the elements of leading diagonal. 3 and 1 we have to interchange. In the place of 3 we have to write 1, and in the place of 1 we have to write down 3. And what is the the remaining elements of 2 into 2, we have to change the sign of remaining elements. Remaining elements means 2 and minus 4. We have to change their sign. If minus 4, no need to change the elements. just we have to, and the sign of the remaining elements, just we have to change the sign, not elements. Sign we have to change. If positive 2, we have to write negative 2. If negative 4, we have to write positive 4. Hope you understand how to find out adjoining A. Main diagonal, we have to change the elements. In the place of 3, we have to write 1. In the place of 1, we have to write down 3. You can see we have to interchange. And non-diagonal, we have to change the sign. If negative, we have to write in positive. If positive, we have to write negative. Hope you understand this adjoint of a matrix. Now look at next, inverse of a matrix. Let A be the square matrix if there exists a matrix B such that AB is equal to BA is equal to I means identity matrix, and the value is 1 0 0 1, then B is called the inverse of A. The inverse of A is denoted by A inverse. This is read as A inverse, therefore B is equal to A inverse of A is denoted by this, and thus A inverse is equal to A inverse A is equal to I. Either A into A inverse or A inverse into A is equal to I. You can see here AB is equal to BA is equal to I means identity matrix. If A is a singular matrix, there exists a new matrix B such that AB is equal to BA is equal to I. Hope you understand this inverse of matrix. The definition you have to remember, and upcoming videos related with determinant, singular, non-singular matrix. If you have any kind of confusion, please comment. If you understand this definition with example, please hit the like button, and if you are new on my channel, please subscribe and share with your friends. Sharing is caring, so please share with your friends. Thanks for watching till last.